welcome back into our discussion, whereby we are still going to discuss about the ordinary differential equation, solving them using the Laplace transform. The first step, we agree that we come and introduce Laplace transform to each and every term of dy with respect to dx. That is our first step, to mean that we are going to have dy squared with respect to dx squared. We come and subtract from 3 the Laplace transform of dy with respect to dt. We come and add to 2 the Laplace transform of y is equals to the Laplace transform of exponential negative 4t. From this point now, we need to get the Laplace transform of dy squared with respect to, here I'm supposed to be having dt. By getting the Laplace transform of this, we understand that we are going to have s squared y bar we subtract from s, y naught we subtract from y1. That is the Laplace transform of dy squared with respect to dt. We come and subtract from 3 into s, y bar we subtract from y naught. We add 2 to the Laplace transform of y is equals to y bar, and here the Laplace transform of our exponential is equals to 1 all over s. We add 2 to 4. I have discussed on how you can go about the Laplace transform of the exponential using the first principle. That is the reason as to why we are having that. After getting the Laplace transform of our function here, now we need to replace our conditions of y and y1. We understand that when you come here, we say that in the introduction part, when you've been given y, it is always equals to y naught. And when you've been given dy with respect to dt, this one is equals to our y1. So this is the most important part that you need to understand. To mean that now we replace the conditions, and now we are going to have s squared y bar we subtract from s, y naught is equals to 1. From there we subtract from y1. y1 is equals to dy with respect to dt, which is equals to 5. We subtract from 3s y bar. We add to our y naught is equals to 1. To mean that when you take a negative of 3, you multiply by 1, you are going to have a positive of 3. We've opened the bracket and replaced the condition. We come and add to 2 y bar, everything is 1 all over that. At this point now, we can come and collect the common terms of y bar, because here we are having a y bar, y bar, y bar. To mean that we can come and factor out the term of y and collect the like terms. S squared, here we are subtracting 3s, and here we are going to have a positive of 2. Our y bar is outside here. We will be left by a negative of s. Here we are going to have a negative of 5, but we are having also here a digit which is a positive of 3. When you add the 2, you are going to have a negative of 2. Everything is equals to 1 all over s plus 4. Now here we can take whatever we are having on this side to the other side, and now we will be having y bar into s squared. We subtract from 3s, we add to have 1 all over s plus 4. We add to s we add to 2. Everything all over 1. Let us now simplify whatever we are having on our left hand side. When we simplify our function here now, we will be having y bar into s squared, we subtract from 3s, we add to 2. Everything is going to be equals to, we take whatever we are having within our denominator here, we multiply by our first term, second term, and the third term. When we do that, we are going to have 1, because when you take whatever we are having here, we multiply by itself, we are going to have 1. We add 2, we take our function here, we multiply by that, and we will be having s squared, because s multiplied by s is equals to s squared. S multiplied by 4 is equals to 4s. We take 2, we multiply by everything, we are going to have a positive of 2s. We add to 8, and everything is going to be all over s plus 4. On our left hand side, we come and divide everything by s squared, we subtract from 3s, we add to 2, so as to end up with y bar. And now here we are going to have s squared, we subtract from 3s, we add to 2. Y bar now is going to be equals to, we can simplify everything on our numerator, and now we will be having s squared, we add to 6s, we add to 9, all over s plus 4 into s squared, we subtract from 3s, we add to 2. Now, we need to have our term of y on our left hand side. For us to have our term of y, it means that we need to understand that the Laplace transform of y is equals to y bar. To mean that when you want to go back to our term of y, you must get the inverse Laplace transform of y bar, which is going to be equals to y. When I introduce here the inverse Laplace transform of y bar, for us to have the term of y, also on this side I must introduce the term of y bar. And now we are going to have, from this point now, we are going to have y is equals to the inverse Laplace transform of s squared, we add to 6s, we add to 9. Everything is going to be all over s plus 4 into, we can simplify our second order linear equation using factorization. And when we simplify our linear equation here using factorization, now we are going to have, let's say it is s squared, we subtract from 3s, we add to 2. We know that product, we are going to have the coefficient of the term of a, the coefficient of s, we multiply by our term of c, which is equals to 2. Sum a negative of 3. Factors now, we are going to have our factor as a negative of 2 and a negative of 1. Because when you take this negative 2, you multiply by negative 2, you must get a positive. And when you add them, you must get a negative of 3. To mean that now we are going to have s squared, we subtract from 3s, we subtract from 2s, we subtract from s, we add to 2. We come and factor them. Then our negative here is going to affect whatever we are having within the bracket. And we have a common factor on our first bracket to be equals to s to be equals to s into s, we subtract from 2, we subtract from 1. The negative sign here is going to affect whatever we are having within the bracket, as we subtract from 2. And now we can come and have a common factor of s minus 1 into s we subtract from 2. We can come and say our inverse Laplace transform, we are going to solve it now using the partial fractions, whereby now our partial fractions will be the inverse Laplace transform of a all over s plus 1, we add to b all over s minus 1, we add to c all over s minus 2. These are now our partial fractions. From these partial fractions now, we need to get the value of a, b, and c. And for us to get the value of a, b, and c, we are going to use the cover-up rule. By the cover-up rule, this is what I mean. For us to have the value of a, we must get the conditions of our limit, whereby now we are going to say s plus 4 is equals to 0, to mean that s is equals to a negative of 4. We come and say now limit to the term of s approaching a negative of 4 into s squared, we add to 6s, we add to 9 all over, we cover up our term of a, and now we are going to have s, we subtract from 1 into s, we subtract from 2, and everything is going to be equals to, we understand that our term of limit, our term of the, we understand that our term of s approaches a negative of 4, to mean that negative 4 squared, we add to 6, we multiply by a negative of 4, we add to 9 all over a negative of 4, we subtract from 1 into a negative of 4, we subtract from 2. Here now we can come and have 16, we subtract from 24, we add to 9. 1 all over, on our denominator here we are going to have a negative of 5, and here we are going to have a negative of 6, to mean that we are going to have a positive of 30. This is now our value of a, to mean that the value of a, let me have it here, a is equals to 1 all over 30. Let us get the value of b, still using the cover-up rule. The value of b, s to the s subtract 1 is equals to 0, to mean that s is equals to 1. Limit the condition of s approaches a positive of 1 into, we are going to have s squared, we add to 6s, we add to 9, everything is going to be all over. We come and cover up our term of b, s plus 4 into s minus 2. That is the reason as to why we refer to our method as cover up. We understand that the condition of s, the term of s approaches 1, to mean that we are going to have 1 squared, we add to 6 into 1, we add to 9, all over 1, we add to 4 into 1, we subtract from 2. Here now we are going to have 1, we add to 6, we add to 9. To mean that we are going to have 16 all over. Here we are going to have 5, negative 1. When you multiply the two, you are going to have a negative of 5. And now our term of b is equals to negative 16 all over 5. Let us now get the value of c. For us now to get the value of c using the cover-up rule, as we subtract from 2 is going to be equals to 0, to mean that s is equals to a positive of 2. Limit to the term of s approaching a positive of 2 into s squared, we add to 6s, we add to 9, everything is going to be all over. We come and cover up our term of s, and now we are going to have s, we add to 4, into s, we subtract from 1, everything is going to be equals to 2 squared, we add to 6 into 2, we add to 9, everything is going to be all over. 2, we add to 4, into 2, we subtract from 1. On our numerator here, we are going to have 4, we add to 12, we add to 9. To mean that on the numerator, we are going to have 25 all over. Here we are going to have a positive of 6, we multiply by a positive of 1 all over 6. The term of c now is equals to 25 all over 6. Up to this point now, we have the values of a, b, and c. And we got those values using the partial fraction, whereby we applied the cover-up rule. Now, from this point, we can come and rewrite everything and say that we understand that whatever we are having here is equals to whatever we are having on the other side. Now we will be having y is equals to a we understand that y is equals to everything on the other side. The value of a is equals to the inverse Laplace transform of the value of a is equals to 1 all over 30. Everything all over s plus 4. To mean that I'm just replacing the values of a, b, and c. The value of b is equals to a negative of 16 all over 5. And everything is going to be all over s. I subtract from 1. I come and add 2. The value of c is equals to 25 all over 6. Everything all over s. I subtract from 2. Now I need to get the Laplace transform of each and every term. to mean that I will be having now y is equals to, here I'm going to have 1 all over 30, the inverse Laplace transform of 1 all over s plus 4. I subtract from 16 all over 5, the inverse Laplace transform of 1 all over s. I subtract from 1. I come and add to 25 all over 6. The inverse Laplace transform of 1 all over s, we subtract from 2. We understand that the Laplace transform of exponential, positive or negative at, is equals to 1 all over s, negative or positive of a. When you check at whatever we are having here, you will find that it matches our first condition on the denominator, second condition on the denominator, and the third condition on the denominator. To mean that now, we are going to have y will be equals to 1 all over 30 exponential. Here we are having a positive of 4a to be the term of s, to be the term of a. When we are having here a positive of 4a, the coefficient of t on the exponential is going to take a negative of 4t. We are done with our first term. We come and subtract from 16 all over 5 exponential. We are having now negative of a, here negative 1. To mean that here now we are going to take a positive of a, and now we will be having 1t, which is equals to t. We come and add to 25 all over 6 exponential. We are having a negative of a, to mean that here now we are going to have the coefficient of t will be equals to a positive of a, which is equals to a positive of 2t. And this is how you go about solving a rabbit the ordinary differential equation that we were having. Now, using Laplace transform. This is now your answer. Thank you for your time. And for those of you who have been subscribing to my channel, I also congratulate you for your subscription and support. Let us now meet in my next session, whereby I'm going to discuss about a couple of examples on differential equations still using the Laplace transform. Thank you so much.